a student, his mind only goes to the information in which he or she has um, gotten access to before. Now, that is not the, I don't want to say that is not the correct way of seeing things, but your mind has to go further than that. For example, if I say mention objects, you'd mention a car, a human being, a building. But those are things we can touch, and those are the things your mind goes to immediately. But as a developer, there are things in which you can't touch, which are also objects. For example, invoice. For example, receipt. For example, school fees. For example, payment. For example, department. For example, faculty. For example, payroll. If I was to tell you that, oh, you belong to a particular department, and I tell you, okay, for you to make 1 million Ghana cedis, bring me the department. Go and touch the department and bring that department to me. There is a certain level of understanding that the department in which I've told you to bring, you can bring it. Funny enough, you can bring it. And that statement, you can't bring the department. But if I was to say, oh, if you come to the school and you take the departments, it is the IT department in which the students are not clever, you may be offended. Why are you offended? Can you touch the department? Can you hold the department? If you're in town and it's mentioned your department, is your department written on your forehead? The word department allows you to acknowledge some certain points. And the points are number one, that because you belong to a particular department, you have a name for it. IT department, computer science department. There's a name for it. If I ask you who is the head of your department, you would mention the name of someone. So there are certain characteristics that make that thing. And if you put those characteristics together, then you have an object. If I call you a student, what makes you a student? That is the discussion we are having now. What makes you a student? The thing that makes you a student is your name, your date of birth, your ID, the department you belong to, and so on and so forth. Now, if you are a student and you don't have any of these things, then we cannot say that you were a student. So, for me to make you a student, I must classify all the information that make you who you are. The classification of that information presents me with a word called a class. The job of the class is to help me to classify my objects. Is to help me to build an environment for my objects. Is to help me to create a world for my objects. So much so that I can define an object. So a class allows me to define an object. And what does that entail? It means that over here, if I say, oh, if the thing has a name, a date of birth, a department, then that thing together, we can call it a class student. So it means that for me to have a student, that person must have a name, Fred, a date of birth, and a department. Now, this group of information together gives me the object. So a class defines the object, and an object is an instance of a class. The word instance means one of. So if I have a group of information and I create one of it, then I've created an instance of it. Now, as a student, I can't use you, but as individuals, I can use you now. But the most wonderful thing about classes is that we are not just focusing on the information that makes you up, which is called the attributes. We are also focused on the actions you perform. What actions do you perform? What do you do? What can you do? So I'm not just looking at, oh, okay, you are a class, so you can. That's not all I'm looking at. I'm also looking at what can you do? What can you do? Now, in programming, when we say what can you do, then we are calling it a what? A method. Or in other languages, a function. So anytime I define a function, I'm defining an action. I'm saying, what can I do? So a class has two separate sections. A class has the attributes. A class has the attributes and the methods. The methods allow us to define who we are, what we will do, when we will do it. For example, if I take a student, what can a student do? Oh, he can study, he can register, he can open the module. So it means that I will not only code the information I can save about you, but I'll also code the actions you as an object can perform. For example, if I take the object person, we can see that every single human being is a person. Now, what information can we save on a person? We can say the person has a unique ID, name, age, city, and gender. What can a person do? A person can eat, study, sleep, and play. Oh, okay. Now, if I create one person, call that person John, say that John is 35, John lives in Delhi and he's a male, then I have created an instance of the class, which is an object. So if I define the properties of a particular object, then I've created a class. But if I create one of them, one which I can use, for example, if I say, oh, let's go and look at the record of John. We can say, oh, John's age is 35. I can use it. I can say, John, eat. John, sleep. Do we understand, please? Are there any questions, please?
No, sir, we are fine.
Mm. One other reason why we do classes and objects, in which, um, to be honest with you, is the true reason why we do it, is that if I say int a is equal to 0, or here let me use I, int I is equal to 0, what I have done is that I have told the computer that I have a space, and the space in which I have um, has an address called I, and in I have put there an integer, and this makes sense to us. How does the computer know that 0 is an integer? Why doesn't the computer recognize that um, this 0, maybe I'll make it A, and it should be correct because A is an integer? Why does the computer think that 0 is an integer? Now, this idea is a very important idea because the computer already has defined everything that makes an integer an integer. So the moment in which I say int I, the computer goes and gives all of the rules that govern integer to the space I. Now, another word for the integer and the double and the float and all of them are primitive data types. The word primitive data types that comes in this scenario over here, the word that pops up here, means that if this is you're a primitive person, you're the bottom barrel, you came from there, it is there that you are, you came with it, you're a native of the place. So primitive data types are the data types that came with the language. So their properties are defined already. What happens if I want to create my own data type? I want to create my own data type. How do I create my own data type? I want a data type. How do I create my own data type? Now, I'll create my data type by defining the rules that govern it. Then I'll create an address so that the rules that govern it should be put there. I'll tell the computer that I have created a new data type and it should go into this location to find the rules that govern it, and then take the rules from here and put it in the space and use it to define what I am doing. Now, what I have written over here is exactly the same as what is over here. You can see we have int I, we have scanner con. The difference comes in here. The computer already knows the properties to govern this by, so it doesn't ask you for them. But when you say scanner con, the computer doesn't know the rules to govern scanner with because it's not primitive. It didn't come with scanner. It does not belong to scanner. So the computer is asking you, is this thing a new data type? That's why the word new is there. And when you say it is new, it tells you, okay, where are the rules that govern it? So if I wanted to create my own data type called person, I would create the person. I would create another word person here. It is here that students get crazy. But sir, you wrote person and wrote person again. Oh, sir, over here is scanner code. But if I change this one to scanner, oh, sir, why did you write scanner twice? I'm confused. Why are you confused? Where is the confusion from? One of the words starts with a capital letter. We know that everything that starts with a capital letter is a class. The second thing doesn't start with a capital letter, which means it is a variable or a method. We also know that if I am creating and defining something, I need the data type and I need the address of it. I need the data type and I need the address. That means that the one of the small letter is the address of the thing, is the location the item is going to be holding. And this here defines the class. We have seen that the class is me defining the rules that govern the thing. So if I've defined the rules that govern the thing, and I've defined the location that the rules should be kept, where are the rules? So I just tell the computer, oh, what you see there is a new rule I'm creating, and go and find all the rules inside the scanner, the class called what? Person. Ladies and gentlemen, this is how we define an object from a class. Technically, what we have done is we have told the computer we are creating an object from the class person. The object we have created, here's where you can find the rules that govern it. And the rules that govern it can be found in a word called a constructor. This here is a constructor. If it was this alone, then it is a class. But because of the bracket, it becomes a constructor. The job of the constructor is to append the rules to the object. Now, because the thing is a new rule you are calling it, you can't call it a variable. You have to call it an object. Do we understand? Are there any questions, please? Are there any questions, please? If there are no questions, then let me come here. Over here, I have my code. I'm going to create a new project. I'm going to call this project School Management. Or let's just call it Management. And then in here, I'm going to say you should add sample code and click on Create. So here we have seen this in our previous class. I've just opened a new file in my IntelliJ. So now I have this file opened up in my IntelliJ. I have my main Java class. I'll right click here and I'll go to new and I'll click on Java class. And then in here, I'm going to put in the name of the class I want to create. Note that there are other specific or specify or what word special classes that are also there, like the interface, the record, the enum, the annotation, the acceptance. They are all classes, but they are specialized classes and they all have a purpose. But for us, we are just going to create a class, and I'll just make sure class is selected. Remember, all classes start with a capital letter, so I'll start with a capital letter 2, and then in here, I'll call my class student. In here, I'll have to define the attributes of my class. The attributes of my class define the properties of the class. So for you to be a student, you must have an ID. For you to be a student, you must have a name. For you to be a student, you must have an age. For you to be a student, you must belong to a particular department. Wonderful. Wonderful. Now, I must also define the methods, the actions the student can do. For now, the only action I want to do is I want to be able to display all of the elements of the student. I want to be able to see all the things in which I have created over there. So I need to create an object to do that. I'll say void. I'll say public. Void, which means it has no return type. It will not save any information. And then I have to give the name of the method. The method is going to be called display info. And then in here, I'll put this variable over here. In here, I need to define the stuff. So here I have system dot out dot print. And then in here, I'm going to say the person's ID is equal to the ID of the student. Perfect. Um, just so that everything is okay, I'll put them all in different lines. Just bear with me for a second. And then I will do this so that I can just do this. Oh, let me put name over here rather. And then over here, let me do age. And then over here, let me do department. Wonderful. Wonderful. Now, with this all set up, I have defined my attributes and I have also defined my action. Over here, I need to run my code. All code would run in the main method. No matter where the class is, it will always run in the main method. So in here, I'll tell the computer that, oh, I've created a class called student. Now, I want you to create just one student out of that class. It is a new class I'm creating called student. So I've done this. Now, when you take student one, go and take his ID and set it to 12. When you take student one, go and take his name and call him Fred. When you take student one, go and take his age, and his age is 12. when you take student one, full stop, and you see that when I bring the full stop, it gives me the properties, the things in which you have over here. Can you see that? It shows me all of the properties in which I have defined of the student, and I want the department to be IT. Wonderful. Now, when you take student one, go and display the information about student one. So when I click on play over here, I should see my code will build. I have no errors, I have no problem. So here, what do I see over here? I see ID is equal to 12, name is equal to Fred, that is equal to that, that is equal to that. The beauty of this is I can create another student if I want to. So over here, I have student 2. So I can also go through this whole same process again and say that, oh, student two's ID is 11, student two is called Yeah. Student two has an age of 13, and student two is doing computer science. So I can just tell the computer to also go and display the information on student what. By the way, over here, I didn't change these items to 2. So let me just do that very quickly. So that now when I go and click on the run button again, it will compile and it will tell me that, oh, I have ID this and then I have ID that. But you see, here's where the problems start to come in. I have been able to define who a student is. That is great. But you see, um, as a human being, everything about you is kept private. Sometimes your facial expressions will reveal the kind of person in which you are. You know, your facial expressions. It will reveal the kind of person in which you are. If you are a kind person or not kind person, your facial expressions will show. So sometimes, not all the time, but sometimes your face will give away what you are thinking. But if you love someone, you find someone annoying, you don't, or whatever in which you have in your brain on a particular individual, no one will know. No one cares. Now, the same way, if we are saying that this is the definition of you, then how you run, how you behave, how you think, no one should have access to it. It should be kept private to you. Everything you have should be contained in you and you alone. So that only when you want to reveal something about someone is when you reveal something about someone. It is only at the point in time you want to give information about someone. It's only at the point in time you want to say something about someone is when that information can be said. And that presents us with the concept of encapsulation. Encapsulation is saying that everything about you should be contained in a capsule. Should be contained, should be held. So much so that no one should know anything about you. And how will I implement that? I'll tell the computer that the information here should be private. It should be private. It should be private. It should be private. And if the information here is private, then it means that all of these things here are wrong, because if I go and type student again and I press dot, I don't see them anymore. I shouldn't be able to see your innermost thoughts, your innermost, I shouldn't see them. It is here that you start to hide things from someone. You start to make your code safe. It is here that you start thinking of, oh, how do I protect my code? How do I protect my customers? The customer sends you his bank account number. You can't reveal his bank account number. Only he has to know his bank account number. The customer's name, the customer's phone number. Only he has to have his phone number. But if I am hiding it from here, then how do I go and know the person's name, age, and stuff? And it is there where an observation has to be made. You can see that we have brackets over here, but here there are no brackets here. So where are these brackets coming from? By the way, we said that this here is the class. You can see class student. But I told you this here is called constructor. So where is the constructor? Where is it? By default, if you create any class, a constructor is created for you automatically. Now, you can override it and create your own constructor. How will you create your constructor? You just say public, the name of the class, and then your curly brackets. And you can see I'm getting no error because over here, this is the constructor. So the computer knows that this constructor is created for you automatically. To be honest, you can have more than one constructor, especially in situations where you have more than one way of creating something. For example, you can have an employee who is a 9 to 5 worker. You can have an employee who is a part-time worker. You can have an employee who is a contract worker. So each of them are all employees, but how they'll be treated will be different. I can have a student who is an undergrad, a student who is a graduate school, a student doing pre-university. They are all students, but they all can be treated differently using one element to treat them like that. So how they will be built would be different. So I can have multiple constructors. In this case, I want to create a constructor. I want my constructor to have all of this information. So the same thing, I have public student, but in here, I'll put string ID, string name, this and that, so that that information would be collected. So that when I come here, instead of me just putting students here, I'll say, oh, the person is 12, comma, the person has a name or Fred, comma, the person is 12 here, the person is doing IT here. So that everything is on one line. Again, if I go to display, it will display to tell me that, oh, the person is 12 and he's Fred and all of those things here. You can see that it is here. But as to where the information here is saved, how it is saved, when it is saved, you don't know. We are going to be thinking like this during our semester. Our semester will, from next week when we come, we'll take encapsulation and then abstraction because they normally go together, and have a full class defining what they are and discussing them and having multiple examples of how they work. Our classes are going to be more conceptual and implementation of code this semester. The days of write a program to do this are over. Now, we are not just writing a program, but we are writing a program that is more secure, more founded, more grounded in code. Please, I am begging you. The days in which you take coding classes like it's a joke are over. Take it seriously now. Are there any questions before we go away for the day? If there are no questions, thank everybody for coming today. Have a blessed weekend. And as always, we'll meet again next week.